47 engineers. That's the number that reportedly left South Korea's advanced packaging sector over a relatively short period. And in most industries, that wouldn't matter very much. 47 accountants don't change global finance. 47 software developers don't rewrite the internet. But 47 packaging specialists working at Samsung, SK Hynix, and their suppliers? That can shift the balance of an industry worth hundreds of billions of dollars. Because despite all the headlines about artificial intelligence, giant data centers, and trillion-dollar technology companies, there is a quiet reality sitting underneath the entire AI boom. None of it works without advanced packaging. You can have the most sophisticated chip design ever created. You can spend tens of billions of dollars building fabs. You can even master the process of manufacturing transistors measured in billionths of a meter. Yet if you don't know how to stack memory, manage heat, connect thousands of microscopic pathways, and package multiple chiplets into a single high-performance module, you're still standing outside the most profitable room in modern technology. And Beijing seems to understand that perfectly. Over the past few years, China has spent enormous amounts of money trying to build a domestic semiconductor industry that can survive sanctions, export controls, and geopolitical pressure. Washington restricted access to advanced lithography tools. The Dutch government tightened exports. Japan followed with its own measures. The assumption in many Western capitals was straightforward: limit China's access to equipment, and technological progress slows down. That argument isn't irrational. Extreme ultraviolet lithography machines remain extraordinarily difficult to obtain. Companies such as ASML occupy a position that almost resembles a monopoly. If you can't buy the tools, eventually you'll hit a wall. Except technology isn't built by machines alone. It's built by people who already know what mistakes not to make. And that's where this story becomes much more interesting. Reports emerging from South Korea suggest Chinese firms have been approaching experienced packaging engineers with compensation packages that sometimes exceed 2 or even 3 times their existing salaries. Some offers allegedly include housing allowances, private schools for children, research budgets, and contracts designed around one thing above all else: experience. Not patents, not blueprints, not trade secrets copied onto a USB drive. Experience accumulated over 20 years of solving problems that never appear inside textbooks. There's a reason companies guard senior packaging engineers so carefully. A process called HBM integration, short for high bandwidth memory integration, requires extraordinary precision. Tiny defects can ruin an entire batch. Heat distribution behaves differently when memory layers are stacked vertically. Signal interference appears in unexpected places. Someone who has spent a decade fixing these issues carries knowledge that cannot simply be downloaded. Think about it this way. Buying semiconductor equipment gives you the kitchen. Hiring people who already cooked thousands of meals gives you the chef. And China may have decided that importing chefs is faster than waiting for culinary school graduates. I have to admit something here. I used to think China's biggest challenge was obtaining machinery. I'm less convinced today, because machinery eventually depreciates. Human expertise compounds. And if Beijing really launched a coordinated effort focused specifically on Samsung's top packaging specialists, then this isn't a normal recruitment campaign. It's an attempt to purchase time itself. Of course, there is another side to this argument. South Korea still possesses one of the deepest talent pools in semiconductor manufacturing. Samsung remains years ahead in several packaging technologies. Experience isn't instantly transferable. Engineers moving abroad don't automatically recreate an ecosystem that took decades to build. That's true. But history offers an uncomfortable lesson. Industries rarely collapse because competitors invent something magical. More often, they lose people. Taiwan gained talent from the United States decades ago. American aerospace companies recruited German scientists after World War II. Silicon Valley itself became powerful partly because brilliant engineers from around the world chose to stay there. Talent migration isn't unusual. What's unusual is seeing it happen at the exact moment advanced packaging has become arguably more valuable than transistor scaling itself. Remember that number from the beginning: 47 engineers. We'll come back to it later because the real question isn't whether they left. It's whether 47 people are enough to shorten China's semiconductor journey by an entire decade. The semiconductor industry likes to talk about nanometers because they're easy to visualize. 3 nanometers, 5 nanometers, 7 nanometers. Investors understand those numbers. Politicians repeat them. Journalists put them in headlines. Packaging specialists rarely receive the same attention. That's strange because companies making AI accelerators have quietly discovered a painful reality. Shrinking transistors is becoming harder, more expensive, and in some cases less rewarding than connecting several chips together efficiently. NVIDIA learned this lesson years ago. Its most advanced AI processors don't depend solely on manufacturing breakthroughs at TSMC. They also rely heavily on sophisticated packaging methods such as CoWoS, allowing GPUs and stacks of HBM memory to communicate at incredible speeds. Without advanced packaging, the performance gains collapse. A processor can think very quickly, but if data arrives slowly, it's like hiring a Formula One driver and asking him to navigate rush hour traffic. This explains why Beijing's interest in packaging talent makes strategic sense. China already has companies capable of producing mature semiconductor nodes. Firms like SMIC demonstrated they could manufacture 7-nanometer class chips despite export restrictions. The surprise wasn't that they managed it. The surprise was how quickly they managed it. Western analysts spent years debating whether sanctions would permanently freeze Chinese semiconductor progress. Instead, China adjusted. Some projects failed, others burned through billions of dollars. Yet certain segments continued moving forward because engineers found alternative approaches, redesigned production steps, and accepted lower efficiency in exchange for independence. Advanced packaging offers another shortcut. You don't necessarily need the smallest transistors if you can cleverly combine multiple chips into one package. Several smaller components working together can sometimes rival a single cutting-edge processor. The industry calls this heterogeneous integration. Normal people might call it technological improvisation. And sometimes improvisation works remarkably well. There is a company that rarely appears in mainstream discussions, JCET Group. Most viewers probably haven't heard of it, even though it ranks among the world's largest outsourced semiconductor assembly and testing companies. Back in 2015, JCET acquired Singapore-based Stats ChipPak for approximately $1.8 billion. At the time, many observers treated it as another overseas acquisition. Looking back, it feels more significant. China wasn't simply buying factories, it was buying institutional memory, engineers, relationships with customers, manufacturing habits, lessons learned through expensive failures. People tend to imagine industrial competition as countries building giant facilities from empty fields. Reality is messier. It's usually an accumulation of small advantages. One engineer knows how to reduce thermal stress by adjusting materials slightly. Another understands why a production yield suddenly drops from 95% to 70%. Someone else remembers a problem encountered 8 years earlier and solves it within an afternoon. That knowledge rarely appears in manuals. It lives inside conversations, inside instincts, inside people. Samsung understands this better than almost anyone. The company reportedly increased retention efforts for experienced semiconductor workers over the past several years. Bonuses improved, compensation packages expanded, internal programs became more aggressive. Because replacing a veteran packaging engineer isn't like replacing an employee at a retail store. Training someone to perform routine tasks might take weeks. Training someone capable of diagnosing microscopic defects inside stacked memory architectures can consume years, sometimes decades. And there is another layer many people overlook. South Korea has demographic problems. Birth rates remain among the lowest in the developed world. Fewer young engineers entering technical fields means competition for experienced specialists becomes even more intense. China doesn't necessarily need to recruit thousands. It may only need several hundred exceptionally capable individuals spread across key disciplines. That's enough to accelerate learning curves significantly. Of course, critics argue that experience alone cannot compensate for missing tools. They have a point. ASML still dominates extreme ultraviolet lithography. Applied materials remains essential in multiple equipment categories. Lam Research and Tokyo Electron continue supplying machinery difficult to replicate domestically. China cannot simply hire its way around physics. I agree with that, but I also think critics sometimes underestimate how much engineering is trial and error. Semiconductor manufacturing resembles cooking more than mathematics. Two factories can possess identical recipes. One produces excellent results. The other wastes ingredients for months. The difference is usually the people standing next to the ovens. There's a mildly amusing irony here. Governments around the world spend years negotiating export controls, drafting policy papers, and issuing statements filled with diplomatic language. Meanwhile, somewhere in Seoul, an engineer receives an offer promising triple his salary and an apartment overlooking Shanghai. Sometimes geopolitics arrives disguised as a job interview. And that brings us back to those 47 engineers. Because the real issue may not be whether Beijing recruited them. The real issue is understanding who selected them. Was this merely several ambitious companies competing for talent? Or was someone mapping entire production chains, identifying bottlenecks, and targeting the exact people capable of removing them? The answer changes how we should interpret everything that's happening. There is something about this entire story that doesn't fit the usual narrative. For months, discussions about China's semiconductor ambitions have revolved around one assumption. If Beijing eventually catches up, it will do so by reproducing what already exists. Build domestic equipment, subsidize local champions, wait patiently, repeat. But what if that isn't the strategy at all? What if China looked at the semiconductor industry and concluded that chasing yesterday's technology was a losing game? Because packaging changes the equation. A company struggling to manufacture a monolithic 3-nanometer chip can still compete if it becomes exceptionally good at assembling several less advanced chips into a highly efficient package. AMD already proved this concept works. Its EPYC processors rely heavily on chiplet architecture. Apple combines different components into tightly integrated systems. NVIDIA's latest accelerators increasingly depend on packaging innovations to unlock performance. In other words, the future of computing may involve connecting chips better, rather than making individual chips dramatically smaller. And if that's true, then Beijing might not be trying to catch up. It might be trying to skip a chapter. That possibility deserves attention because it forces us to reconsider what success actually looks like. For years, analysts measured semiconductor leadership almost exclusively through process nodes. 5 nanometers, 3 nanometers, 2 nanometers. Those milestones still matter. But demand for AI hardware is growing so quickly that packaging capacity itself has become a bottleneck. TSMC reportedly struggled to expand CoWoS production fast enough to satisfy customers. Lead times stretched, orders piled up. Companies with billions of dollars ready to spend suddenly discovered that obtaining advanced packaging slots was becoming nearly as difficult as acquiring the chips themselves. Think about that for a moment. The industry spent decades obsessing over transistor density. Then artificial intelligence arrived and reminded everyone that connecting components efficiently can be just as valuable. This is where my own thinking changed. Initially, I assumed recruiting experienced Samsung engineers was primarily about improving manufacturing capabilities. I don't think that's the entire picture anymore. I suspect this effort is also about credibility. Imagine you're a Chinese packaging company approaching NVIDIA, AMD, or even a large cloud provider 5 years from now. You claim your facilities can deliver world-class packaging solutions. How do you convince customers? By showing machines? Partly. By offering lower prices? Certainly. But what really reassures clients is hearing that the production team includes people who previously spent 15 years working on Samsung's most advanced HBM projects. Experience becomes marketing. Experience becomes insurance. Experience becomes leverage. And here's the reversal. Even if Beijing succeeds in attracting top specialists, there is no guarantee China immediately dominates advanced packaging. Because semiconductor ecosystems are stubborn. Samsung isn't merely a collection of talented individuals. It is a network. Material suppliers, equipment vendors, universities, testing facilities, chemical manufacturers, design teams, research institutes. Pulling engineers away from that environment doesn't automatically transfer the ecosystem itself. A violinist can move to another orchestra. That doesn't mean the orchestra instantly sounds like the Berlin Philharmonic. Yet dismissing China's efforts would be equally foolish. People said Chinese electric vehicles would remain low-cost alternatives. Today, companies such as BYD compete globally. People once doubted Chinese drone manufacturers. DJI eventually became almost impossible to ignore. Solar panels followed a similar path. At first, the products weren't exceptional. Then they improved. Then competitors discovered the price difference was unbearable. Then entire industries adjusted. Semiconductors are more difficult, far more difficult. But the pattern feels familiar. Start with dependence, acquire knowledge, improve gradually, reach acceptable quality, scale aggressively, and eventually, someone wakes up wondering how the gap narrowed so quickly. I'm not completely certain Beijing has a centralized list containing Samsung's top 200 packaging specialists. There isn't enough public evidence to say that confidently. But I do believe Chinese policymakers understand exactly where their vulnerabilities lie. And if I were designing a national strategy to survive technology sanctions, advanced packaging would sit very close to the top of my priority list. Because sanctions can delay access to tools, money can accelerate construction, but seasoned engineers? They remain the rarest resource in the semiconductor business. Remember those 47 people from the opening? Maybe 47 isn't enough. Maybe 200 isn't enough either. But if 5 countries are competing for the same pool of specialists, and one government is willing to spend almost without limits to secure them, eventually the math starts favoring the buyer. And that's before we even discuss what happens if Taiwan faces a similar talent drain. That's a conversation worth saving for the end. Taiwan is where this story becomes uncomfortable. Because if Beijing truly wants to reduce dependence on foreign technology, South Korea is only one source of expertise. Taiwan is the crown jewel. TSMC controls more than half of the global foundry market. Its packaging technologies, including CoWoS and SOIC, are becoming almost as strategically important as the chips themselves. Every major AI company is lining up for access, and Taiwan knows it. Over the past few years, concerns about engineers moving to mainland China have grown significantly. Recruitment agencies have been investigated. Some companies introduced stricter non-compete agreements. Authorities discussed stronger protections for critical technologies. That tells us something important. Governments don't worry about talent migration unless they believe talent migration works. And perhaps that's the biggest lesson here. People often describe the semiconductor race as if it's a contest between factories. It isn't. Factories are expensive. Factories can be copied. Factories can even be destroyed and rebuilt. What cannot be manufactured overnight is accumulated judgment. The ability to walk into a clean room, look at a process chart, and immediately know which variable is causing trouble. The confidence to tell management they're chasing the wrong solution. The instinct to recognize a mistake before the data confirms it. That takes years, sometimes an entire career. My own view is fairly simple. I don't think China will dominate advanced semiconductors by 2030, at least not in the way people imagine. I don't expect SMIC to suddenly overtake TSMC. I don't expect Samsung to wake up one morning and discover its technological lead disappeared. But I do think we're approaching a period where the definition of semiconductor leadership becomes less obvious. The company producing the smallest transistors may not capture all the profits. The nation with the most advanced lithography tools may not control every stage of the supply chain. And the countries protecting equipment while ignoring people could discover they've been guarding the vault while someone quietly hired the bankers. That doesn't mean Beijing's strategy is guaranteed to succeed. Far from it. Some engineers won't leave. Others will return home after contracts expire. Corporate cultures don't travel easily. Research environments take decades to mature. Even generous salaries cannot buy loyalty from everyone. Still, there is a pattern emerging. China lost access to certain technologies. Instead of waiting for restrictions to disappear, it searched for detours. Sometimes those detours involve domestic innovation. Sometimes they involve acquisitions. Sometimes they involve recruitment. And occasionally, they involve all three at once. Back to the number we started with, 47 engineers. Maybe historians will look back 10 years from now and laugh at the idea that 47 people mattered. Or perhaps they'll point to that small group as one of the moments when the semiconductor race quietly changed direction. I'm leaning toward the second possibility. Not because 47 engineers can build an industry by themselves, they can't, but because their movement signals intent. Someone identified advanced packaging as a weak point. Someone decided waiting another decade was unacceptable. And someone was willing to pay extraordinary amounts of money to shorten the journey. That tells me this isn't a temporary campaign. It's a long-term strategy. A strategy built on a simple assumption. Machines can be purchased. Buildings can be constructed. Capital can always be raised. But when the world suddenly realizes that a few hundred highly specialized people are worth more than billions of dollars in equipment, the competition stops looking like manufacturing. It starts looking like a global bidding war for experience. My prediction is that within 5 years, advanced packaging engineers will become some of the most sought-after professionals on Earth, earning compensation packages that rival senior executives in other industries. And if that happens, governments may eventually discover that controlling technology exports was the easy part. Convincing talented people not to leave may prove much harder. If you enjoyed this analysis, consider subscribing and sharing your thoughts below. I'd like to hear whether you think Beijing is merely buying time or whether it's buying the future. After all, semiconductor competition has a strange habit. The headlines usually arrive years after the important decisions were already made.